Hopefully I haven't screwed this whole thing up. I'm trying a new mic today. So I remember once, I think it was the best ME 1800 lecture I ever gave. It was in this room. It was, the topic was lean manufacturing. And I knew that I was on fire for the entire lecture. I had a student in the class came up to me at the end of class. He says, I used to work. I came back to school. I did this for a living. This was the thing I did for my job. And that's the best explanation I ever heard. And when I got back to my office and looked at the video, the mic was turned off. So it was just me doing this, which, I mean, I suppose I could watch that for a while, but not for the whole hour. So hopefully we have a mic today. The little receiver is making, like, the green thing is going back and forth. When I checked it on the software, it said the green thing was going back and forth. So I believe that we have this going. Let me see if I can get the projectors turned on here. Press to begin. Left. I guess that's my left, not yours, huh? It's amazing because I guess they've got systems in all the classrooms on campus, but no two podiums are the same on campus. So it's funny. I'll go to like a seminar in some classroom where I normally teach, and you'll see the professor getting ready to give the seminar, and they can't figure out how to turn on the projector. So you get to have a little bit of fun. PC left projector, right projector. Right projector, PC. Okay, but now I got to go back to room control, turn on the right projector. I don't know why I bother. Screen down. You guys could probably all see the one, right? I feel somehow it's important that I turn them both on. I don't know why. And all right, so today's Wednesday, right? Good. Okay. And on Wednesday, some of the people in the class have a conflict. So the fact that it's time to start the lecture. Cool. I'm like, are the cops coming to get me? Did I say something I'm not supposed to? Where was I? Wednesday. Yeah, so getting the recordings correct on Wednesday is important because Wednesday is the day that some of the people won't be in class. I made a change to the schedule on the syllabus. I changed next Tuesday and next Wednesday, I flipped them. We were originally scheduled to talk about the group project next Wednesday, and I'd rather talk about the group project when everybody has a chance to be here. And that way that you can actually in person get together and form your groups and things like that. So I switched Wednesday and Tuesday on the schedule for next week. Should not affect us by the end of the term. Anything else? I guess I want to keep course announcements and stuff like that to the end of the lecture. So that if you're not interested, you can just stop when I start doing that stuff. So let's get started. Quality and high mix manufacturing. Yesterday, No. When I press the space bar, it starts the video again. Nope. One of these days, I'll learn how to do this. All right, so yesterday we briefly described what is high mix manufacturing. Anybody want to recap what we talked about? Chalk. One piece of chalk would be nice. Oh, there's all the broken chalk. So what is, all right, so let's quickly, what is manufacturing? Yes. Making stuff with the intent to sell it. Sometimes I say making stuff people need, but making stuff because we want to sell it. Okay. We talked a little bit yesterday at the end of class about the difference between high mix manufacturing and high volume manufacturing. And I wouldn't use that as a way to say what type of company it is. So when we talk about types of companies, we'll talk about large companies, more than 500 employees. Small and medium companies, less than 500 employees. Most of those are actually small companies with less than 50 employees when we look at manufacturing in the industry. And when you look at this, so they divide them by size of company, number of employees. You'll divide them by industry segment, right? So people will say, well, that's an electronics manufacturer. That's an auto manufacturer. That's a steel manufacturer. And so you divide it by the kind of things they make. And people do that for accounting purposes. The government likes to keep track of the different things and things like that. Accountants like that. Economists like that. But when you're operating the business, and I'd like to think I'm talking to you because I usually do this on the first day of class. Everybody stand up. I should probably save this for about halfway through when you start dozing off. All right. Sit down if you have a trust fund and you never need a job. Okay. One time I did that and somebody sat down. That was kind of fun. I'm pretty sure if I had a trust fund, I would stay standing anyway. And I don't know. Maybe if I was looking for a date. No, I don't think I would want to date the kind of woman who would want to date me because I had money. All right, so that's settled. So all of us that are standing don't have a trust fund. We're probably going to need a job someday. So I want to spend some time, you can sit down now. I want to spend some time in the class talking about things that will not only help us get a job, but it will help us work at a company that doesn't fail. Most of you, who's a mechanical engineering major? Who's not? Okay, so probably 3/4 of the class mechanical engineering majors. I'm going to guess that most of you are going to end up getting a job at a company that makes something. By definition, then that's a manufacturing company. So most of you are going to get a job in manufacturing, regardless of what it says on your degree there. I would like you to be able to identify companies that are going to succeed and companies that are going to fail so that you can work for one that's going to succeed. So we'll talk a little bit about the business side of this stuff. But so where was I just before that? I lost myself. Say again?
Trust funds.
Trust funds. Yeah, before trust funds. That was my little fun thing. I normally do that on the first day of class. Once I had the students complain that I talked too much about business in the engineering class. And after I started doing the trust fund thing, nobody complained about that anymore. Start over. Yeah.
You're talking about like small and large companies.
Small and large companies, segments of companies. Okay. Yeah. So the same company could do high volume manufacturing and high mix manufacturing. But the way you operate the business unit that's doing that, or the way you consider doing those actions, has got to be different between high volume and high mix. That's where I was. All right. So what is high mix manufacturing? We defined it yesterday at the end. Yeah. Right. It's when you don't make the same thing every day, day after day after day. Right. So in high volume manufacturing, the same people are using the same machines to make the same parts day after day after day after day. And the process is very stable. You know what to expect. When you're doing quality assurance and quality inspection in that kind of a scenario, it's very different from when you're doing high mix manufacturing, where you may, well, the order quantity for a part might be one. You're changing over on a daily basis or a weekly basis what it is that you're manufacturing in that machine. And so that's what differentiates high mix from high volume manufacturing. The same company could do both. So quality manufacturing is to give the customer what they need when they need it. I like to add the caveat, at a price that works for everybody. This is especially important in high mix manufacturing, because in high mix manufacturing, you are not the only source that could make those parts. You've got to be able to do it economically. If you can't do it, the customer will go find somebody else. Pricing can be very elastic in certain high mix manufacturing settings. So give the customer what they need, when they need it, at a price that works for everyone. Let's think about the workflow in manufacturing. So imagine you're a manufacturing company and you're in your business unit, your intent is to do high mix manufacturing. So you need to have a source of new work coming in. Does that make sense? All right. And so you'll have some sort of a sales and marketing effort and things like that. And so there's people going out trying to find people who want new parts. And you'll have existing customers who are going to order new parts from you. So you'll have some list of existing customers. And so we're going to ignore all that stuff. You can't ignore it if you actually own the company. But since this is an engineering class, we can ignore that for now. Let's assume that there's a flow of new customers and new jobs coming in, and we'll pick it up from there. What's the workflow? First thing is a request for quote. So a customer, whether it's a new customer or an existing customer, they send you a request for quote. The request for quote will usually include all the specifications for the part that you need. So it'll have drawings, it'll have special lists of specification, things like that, all the information that you need to make the part. Oh, wait. Is this the dream world where your customers send you all the information, or is this the real world where they just upload a SolidWorks file? By the way, it is possible using software like SolidWorks and Pro Engineer and those things. It is possible to include all the information in the file that is the solid model. It is highly unlikely. So when you do this, you want to, it's very convenient for the manufacturer that's using CAM software like Esprit, like we're using here. It's very convenient to get that solid model. It's also necessary to get drawings with dimensions and tolerances and things like that. We'll talk about GD&T, I think, in week 5. So we'll talk about how to do those drawings and the requirements for those. But so it's possible to get that, but it's not likely. I'm going to try something here. I'm going to try, since I'm going to start writing on the board, to make the board bigger. Nope, that's not the one I want. This one, except I want, oh, you guys can't see this. The people at home can, though. I'm going to remove. And now the loose nut, back in his office, will attempt to do a voiceover to tell you what the heck he was talking about while he waved his arms around in front of the blackboard. It starts with a discussion with the students where we list the workflow for high mix manufacturing jobs, going from the customer requesting a quote where they give you information about the specifications for the parts. They give you drawings and specifications, the number that they want, hopefully the date that they want them. At this point, I'm telling a story, and I'm sure that it was a really good story that emphasized some point that I wanted to make. Story finished. I then go on and talk about what you need to do in order to create the quote that the customer has asked for. So you need to know how to make the part. If you don't know how to make the part, you're not going to be able to respond to the customer. You need to decide how you're going to make the part. You need to estimate how long it's going to take to make the part. You need to determine how much stock material you're going to need and how much the stock material is going to cost. With this information, you know the cost to make the part. Once you add in the profit that you desire to make, you know the price you're going to ask for the part, and you can give the quote to the customer. If the customer likes the price you quoted, and they believe that you're going to meet their delivery deadline, they issue a purchase order. That purchase order is really a contract between yourself and the customer that you will make the parts as they specified and deliver them at the time they asked for. At this point, I tell another story. It is about one of the coolest parts of this quoting process. That last line, the thing you need to do is you need to decide how much profit you want to make on the job. You add that to your cost, and then that's the price that you quote to the customer. The cool thing about it is you get to decide. Now, the thing that happens, though, is if you decide to get too much profit,
Your price might be too high. You may value the parts more than your customer values the part, in which case you won't get the purchase order. With the purchase order issued and accepted, the next thing you need to do is plan how you're going to make the parts. You need to set up the machine tool after you've planned how to do the processes and you've written your program. You set up the machine tool, you run the program on the machine tool to make the parts. After you run the program, you inspect the parts. You actually check to see, did you make the parts the way the customer specified them? You package the parts, and then, of course, you ship the parts to the customer. There is one more critical step after we've shipped the parts to the customer that if we don't do this step, we will not be in business very long. That last critical step is you must invoice the customer and ask them to pay you. At this point, I tell a story to illustrate the point that you only get paid for sending the invoice. You don't actually get paid for shipping the parts. You don't get paid for knowing how to make the parts. You don't get paid for making the quote. You get paid for sending the invoice. The customer, on the other hand, is highly unlikely to pay the invoice if you didn't send them parts that meet their need. This is one of the reasons that it's especially important that it's high mix manufacturing to focus on inspection, especially inspecting the parts before you send them to the customer. No matter what we believe when we make the plan and when we send the quote, we don't know if we can make the part until we've actually made the part. This gives us some internal uncertainty. And if we send bad parts to our customers, that's going to lead them to not want to buy from us in the future, even if we fix that problem that time. And what we lose out there then is goodwill from our customers. The value of our company is based on the ability of us to get sales from existing customers and to bring in new customers. And that goodwill from our existing customers is what allows us to continue operating as a manufacturing company. This uncertainty that we have is because our process is really not well defined until we have actually made the part. Before we make the part, we just think we know how to do it. After we made the part, we know that we know how to do it. Next, I describe an example where we're turning a part that has a critical dimension. So we show our lathe with the lathe chuck and the part sticking out of the lathe chuck. We're going to turn down the outside diameter of the part. And before we start the operation, we know that the lathe has a repeatability stated by the manufacturer to be plus or minus 2/10,000ths of an inch. So the manufacturer has told us that the lathe can move to a position repeatedly to within plus or minus 2/10,000ths. The question we ask in the example is, if we have a part that has a diameter with a tolerance of plus or minus 2/10,000ths of an inch, can we make it? To find out, we set up the lathe and we try to make some parts and we measure the diameters that we can make. We'll plot those diameters on a graph. If we add the tolerances to the graph and all of the points that we've plotted on the graph fall between the tolerance, then of course, yes, we can make that part. If, on the other hand, some of the parts we made were outside of the tolerance range, then we really have a question of if we should make that part. Now, some of the parts we make are good, and some of the parts we make are too big, some of the parts we make are too small. If we only need to make one or two parts for our customer, then it's pretty easy, and if the parts are pretty inexpensive to make, then it's pretty easy for us to say, yes, we could make this part. We just have to make sure that we measure all of the parts and don't send any of the bad ones to the customer. If we make them too big, we could always put them back in the machine and make them smaller again. If we make them too small, well, we may have to throw them away, scrap them as we call that, or we may save them as stock material for a job that requires a smaller part. For most of the rest of the class, we reviewed the stuff that we talked about earlier in the lecture, And we introduced some different measurement tools and some different things that the customers may need us to measure. To end the class, we brought back some topics from our first lecture where we discussed what is manufacturing. And of course, manufacturing is making things with the intent to sell them. And most manufacturing is done by manufacturing companies. Now, manufacturing companies want to continue to exist. They want to stay in business. So we brought back the idea that profit equals value minus cost, where the value is determined by the customer, the person who's paying for the parts. And we look back to that RFQ. If you think about it, when the customer requests a quote, what do they really want? What they really want is to be able to hold the part in their hand. And so they want the part. They value the part because it does what they need it to do. They do not, however, value the inspection that we do. We need to do the inspection because we don't want to lose the goodwill. We don't want to send bad parts to our customers. But the inspection just adds cost to the equation. There's one exception to that rule. The inspection adds value to the part when the customer is willing to pay extra because the part comes with an inspection report. Thank you for watching. Thanks for your patience. And I promise that from here on out, I will really super duper try to not screw up the audio during the live broadcast, because this was really a pain to go back and watch myself and try to remember what I was thinking and what I was saying. I'm certain it was way better when I said it live.